Welcome to Bite-Sized Chemistry, where we take big science concepts and we break them down into small, digestible chunks. Today, we're going to be talking about the laws of thermodynamics. And there are four laws of thermodynamics, and they explain how energy moves in the world. Right, so starting from the top, we have what's called the zeroth law. And the zeroth law states that if two objects are in equilibrium with a third, then they are also in equilibrium with each other. And the best way to picture this is to think of Tupperware. So let's say I'm meal prepping and I'm stacking my containers after my meal prep, and I have containers A, B, and C. Well, the zeroth law states that if A and B are at the same temperature, or what's called thermal equilibrium with each other, and B and C are also in thermal equilibrium with each other, then we can assume that A and C are in equilibrium with each other. So that's super easy. And so is the next law. So the next law is called the first law of thermodynamics, and you've heard something similar to this before. This one's called the law of conservation of energy. And remember that the word conservation means to save. So this is the law of saving energy, and it states that energy is neither created nor destroyed, it's just changed. And what this means is that when we have a reaction in chemistry, we're not creating new energy or destroying old energy. So let's pretend I have, like, I don't know, a candle, and I'll light a candle in my bedroom because I want my bedroom to smell good. Well, when I light that candle, it looks like I'm destroying the energy in the candle and creating new energy in the form of light and heat. But that's actually not the case. When I'm burning the candle, I'm changing the chemical energy of the candle in the wax and the oil, and I'm turning it into heat and light energy. I'm just changing it. If I were to measure it, I would notice that the same amount of energy I had at the start of burning the candle would equal the same amount of energy that I have when I measure like the light and heat coming off the candle. Right? So those are the first two laws. The next two are easy as well. Right? So let's take a look at them real quick. The second law. So the second law of thermodynamics states that entropy always increases. And we can reword this by saying that heat moves from hot objects to cold objects. Now, entropy is a real big word, but all it means is chaos, chemical chaos. So when we're talking about entropy and we're talking about moving from hot to cold, what we're saying is that hot objects tend to have more chaos than cold objects because their particles are moving faster than the cold objects are. So, because things want to reach stability, those hot objects which have more entropy are going to move their heat to the cold objects, which have less entropy. And this is going to continue to happen until they both reach the same temperature and therefore have equal amounts of entropy. And finally, we have the third law of thermodynamics, which states that at absolute zero, so super, super cold, entropy approaches zero. And this makes sense, right? We just got through talking about up here about how cold objects have less entropy. So theoretically, if I could cool something down so much to its like absolute zero, then that entropy would also lower all the way down until it's practically nothing. The caveat here is that absolute zero as of right now is impossible. Even in the depths of space where it's super, super cold, there's still entropy. We're not so cold that, particles stop moving. Now that you know the laws of thermodynamics, let's kind of see how we could be asked questions to apply this knowledge. So let's look at this first one here. His first question says that a teacher leaves a cup of hot coffee on her desk, and that 3 class periods later, she notices that the coffee is now room temperature. Which law of thermodynamics explains this? Well, when I break down this question, I see hot coffee and I see that it changes to room temperature. So we lost heat, right? We went from hot coffee to cool coffee. Well, if I look at my four laws, I notice that there's one law that states that heat moves from hot to cold, from hot to cold. And that is the second law of thermodynamics, right? So the law of thermodynamics that explains this is the second law, which states that heat moves from hot to cold because the hot object wants to be in equilibrium with the cold object. So it's going to share its heat and move its heat and its entropy to the cold object. until they reach the same temperature or the same amount of entropy. And so this coffee, as it's cooling down, as the heat is leaving it and going out into the room, it's going to keep cooling down until it's the same temperature as the room, right? Let's look at one more. So this one says a student says that when a nuclear power plant runs, it is creating energy. Is this student right? Why or why not? So if I see this word creating energy, the first thing I should think of is the law of conservation of energy. And so remember that the first law states that energy cannot be created or destroyed. It's only changed. So even though it looks to us like things are being broken down or destroyed in a nuclear plant and new energy is being created, it's just changing form. So based off of this first law, the student is wrong. His statement violates the first law. Okay? Remember, energy changes. It's not created or destroyed. So I hope you feel a little bit better about the laws of thermodynamics and you see some examples of how you could be tested in the future. All right, we'll see you next time.